This is the solution for the 2017 USACO February Contest Silver. Problem 2. Why did the cow cross the road? 2. The long road through Farmer John's farm has n crosswalks across it, conveniently numbered 1 to n. To allow cows to cross these crosswalks, Farmer John installs electric crossing signals, which light up with a green cow icon when it is okay for the cow to cross and red otherwise. Unfortunately, a large electric storm has damaged some of his signals. Given a list of the damaged signals, please compute the minimum number of signals that Farmer John needs to repair in order for there to exist some contiguous block of at least k working signals. The first line of input contains n, k, b. The next b lines each describe the ID number of a broken signal. Please compute the minimum number of signals that need to be repaired in order for there to be contiguous block of k working signals somewhere along the road. Here's the sample input and sample output. So in this sample input, we have n as 10, k is 6, and b is 5. So if n is 10, that means we have 10 crosswalks. So here are the crosswalks numbered from 1 to 10. And b crosswalks don't work. So those b are, in this case, 2, 10, 1, 5, and 9. So here are those broken crosswalks. Now the problem's asking for us to identify a contiguous block of at least k working signals. So we can restate this as a contiguous block of k crosswalks such so that we're trying to minimize the number of broken signals. So in this case, a contiguous block of 6 would look like this. In example 5 to 10, that's 5, 6, 7, 8, 9, 10. That's one contiguous block of 6 elements. Another example would be this. So 1, 2, 3, 4, 5, 6, another contiguous block of 6 elements. In this case, the sampling output is 1 because this contiguous block of 6 elements only contains one broken bulb. 3, 4, 5, 6, 7, 8. That's what we're trying to find. So how do we construct the contiguous blocks? So we can start at n, the last number, and we can go back k blocks. So in this case, k is 6, so that would be 10 to 5. So that's one block, 5, 6, 7, 8, 9, 10. The same process can be repeated for 9. So 9 k blocks back, which is 9, 8, 7, 6, 5, 4. The same process repeats for 8, 7, and so on. But however, we cannot repeat that process for all the numbers. For example, 5, we cannot repeat the process because there are only 4 numbers before 5. And we cannot add a number before 1, so we would stop at 6. So there would be 1, 2, 3, 4, 5 k blocks. So number of blocks is k. So our first idea, which would be brute force, would be to iterate over all k blocks and calculate the minimum for each block, iterate over the block, and calculate the number of light bulbs. And then try to find the block with the least number of light bulbs. However, this would have a time complexity of n squared. The worst case, we would have to iterate over the whole array. And for each block, we would have to iterate over that also. So that's why it's n squared. So that would only pass 50% of the test cases. A better approach to solve the problem is to construct something called a prefix summary. So in this example, the prefix summary would be constructed as follows. So this array is simply the input given, and the prefix summary is initialized with n zeros. So the prefix summary works like so. The ith element, which in this case is 0, 1, 2, 3, 4, contains the number of broken bulbs from the 0th element to the ith element. Since I is 0, 1, 2, 3, 4, we're going to search from 0 to 4. So 0, 1, 2, 3, 4. So there are 3 broken light bulbs in that range. So we place 3 in that value in the prefix summary. The same process is repeated for all the elements. When repeated like that, we will be constructing an array something like this. The reason we have a 5 here is because we have 5 broken light bulbs from the beginning of the array to the end. The reason we have 4 here is to that index we only have 4 broken light bulbs, so we do not include 10 in the prefix summary. So using this, we can answer questions like so. How many broken light bulbs are there from 1 to I? And we can answer this in order of 1 time. So for example, if I was 5, that would be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. So how many broken light bulbs are there from 1 to 6? Well, the value in the prefix sum array at that index is 3. So we know that there are 3 broken light bulbs from 1 to 6, and we can answer that immediately because that value is already pre-computed. We can also answer questions like so. If this is our prefix sum array, we can also answer the number of broken light bulbs from I to j, so not from 1 to j, from I to j, and we can answer this in, again, order of 1 time using the following concept. The prefix sum value at the jth index minus the prefix sum value of I minus 1 index. So using this key concept, we can derive our final idea, which works much faster, and that is, since we can find broken bulbs in order of 1 from any range, from 0 to 5, 2 to 3, in any range in order of 1 time, so we know that immediately, we can iterate over all k blocks with a final time complexity of order of n, and this passes all test cases on their online judge. That's the end of the video, and this is the solution for the USACO 2017 February contest, silver problem 2, why did the cow cross the road 2.